Today we're going to talk a little bit about density. Density is defined as the ratio of mass of an object to its volume. And when we calculate density, we take the mass value that we measure in lab, divide it by the volume measurement that we make in lab, and that gives us our value for density. And the units for density are grams per milliliter, or sometimes they can be grams per cubic centimeter, depending on which units volume are measured in. When we talk about the density of a substance, it is a characteristic for that substance. So we can identify what substance an object is made out of by calculating its density. And we should also know a little bit about what happens to substances that are more or less dense. If we were to take a substance that is more dense and add it to a substance that's less dense, it would sink. And if we were to add a substance that's less dense to one that's more dense, it would float. So a perfect example of that is taking an ice cube and putting it into water. Pure water has a density of 1.00 grams per milliliter. But when water freezes, the mass stays the same, according to the conservation of mass, but the volume increases. The water expands as it freezes in your freezer. So if the volume's increasing and the mass is staying the same, the density decreases. So ice has a density less than liquid water, and that's the reason why an ice cube floats in your glass of water. Now, we did a lab where we measured the mass and the volume of 12 different objects. And we have a graph here that looks a lot like the graph that we collected in lab. We've got our mass along the y-axis in grams. We've got the volume in milliliters along the x-axis. And the 12 mass volume coordinates are put onto our graph. Now, when we look at that data, we can see a direct relationship. As the mass increases, the volume increases. We also should notice that there are two distinct patterns or relationships on our graph. And when we graph data, we often want to see if there's a linear relationship. So in this case, we have two linear relationships. And whenever we have a line on a graph, we can calculate the slope of that line. So we pick 2 points that are on the line, and we take our y2 minus y1 divided by x2 minus x1, and that gives us the density of our line. Now, since we have two different lines, we have two different slopes. So let's look at substance number 1. And in lab, we identified substance number 1 as being aluminum. When we look at the line that we draw on our graph and we calculate our slope, we come up with 2.70 grams per milliliter. And the slope of that line is equivalent to the density for aluminum because our mass is on our y-axis and our volume is on our x-axis. Now, if we look at substance number 2, that line has a greater slope. When we take two coordinate points on that line and take our change in y over our change in x, we get a density of 8.92 grams per milliliter. So we can use the density of an object to identify what that material that makes up that object is. Now we're going to do some math problems that involve this density equation. So our basic equation is density equals mass over volume, or the grams we have in a given milliliters of space. And if we're given the mass and we're given the volume values, we would plug those into our equation and calculate our density. But sometimes we're given the volume and we're given the density and we're asked to calculate the mass. So we would manipulate that original equation by multiplying both sides by volume, and we would get a new equation. Mass equals density times volume. So if we have our density in terms of grams per milliliter, and we multiply it by our volume units of milliliters, the milliliters would cancel out and we'd be left with grams, which are our units per mass. Now the third variable we might want to calculate is our volume. So if we take that second equation and divide both sides by density, we'll be able to solve for volume. So volume equals mass divided by density. So if we have our mass value in grams and our density in grams per milliliter, in this case the grams will cancel out and we'll be left with our units for volume, which are milliliters.